Hey Kinks, so continuing on with the notes, we have example 1b. They want us to graph and solve this cubic root. So it's the third root of 2x minus 5 minus 2 equals 3. We'll do the same thing by taking it apart. So we'll say y3 equals this cube root of 2x minus 5 minus 2. And we'll say y4 equals 3. So again, y4 equals 3, that'll be a horizontal line through positive 3 on the y-axis. Okay, so our first step is going to be to find the, what do we say, the x-intercept first? So that means y equals 0. So we'll have 0 equals the cube root of 2x minus 5 minus 2. So I add 2 to both sides. That gets me 2 is the cube root of 2x minus 5. Now in this case, last time we squared, but it's because we were working with the square root. This time we're going to cube because we're working with the cube root. So we use a 3 as our exponent. That gets me 8 on the left side and 2x minus 5 on the right. I'll add 5 to both sides because I'm trying to get this x by itself. That gives me 13 equals 2x. And should we just write this as 6.5 or 13 over 2? I'm going to say 6.5. So that's going to be our x-intercept. It's 6.5 comma 0. Because again, we plugged in 0 for y, so that's why we're using the 0 down here. Our second step will be to find the y-intercept, and that occurs when we let x equal 0. So we have the cube root of 2 times 0 minus 5 minus 2. So this becomes the cube root of negative 5. Again, that's totally okay because it's a cube root. So whatever this number is, the fact that it's negative is alright because it'll be a negative times a negative times a negative, which will still be negative 5. We will need our calculator for this. Can you see this? Okay, let's see here. So I have, in parentheses, negative 5 to the 1/3. That gets me this negative 1.7, and then I'm going to subtract 2 from that, and I get negative 3.7 is what we'll use. So we'll say y3 is approximately negative 3.7, and that gets us the point 0, comma negative 3.7. So our third step has been to create a table, and since our index is 3, we would like to get 2 more points. So we have a total of 4 points to graph. Because the cubic root curves around a little bit more. You'll see in a second. So far we have when x is 0, we have 6.5 here. Let's use negative 6.5. And what other, we'll still want one more value. Negative 6.5. Then we have when x is 0, it's negative 3.7. Should we use positive 6.5? We know that's 0. And then maybe we want to use 13 here. Okay, so anyways, when I plug in the negative 6.5, the cube root of 2 times, I'm going to put it back over in a fraction form if that's okay. So then these cancel, and I'm left with the cube root of negative 13 minus 5 minus 2. So this is the cube root of negative 18. And I'm not super interested in trying to simplify that at all, to be honest. So the cube root of negative 18 looks like this in my calculator. There's a terrible glare on the screen, you can't see that. Is that better? And then I'm going to subtract 2 from that, and it gets me negative 4.6. So that's the value I'm going to use here. So if we use, what number do we want? Let's use since I've got two negative y values, let's use something larger than 6.5 in order to get another positive y value. Let's use 13. Let's see what happens there. So when y3 equals the cube root of 2 times 13 minus 5, careful with your radicals there, please. That gets me, that'll be 26 minus 5, I perceive to be 21. So 21 to the 1/3 power. 21's positive, that's why I'm leaving off parentheses here. And then if I subtract 2 from that, I get, do I believe that? I get 0.75. Yes, that makes sense. I'm going to call that 0.8 for our graphing purposes. Okay, so now, let's see. Let's make a graph. And I notice the x values are getting pretty big pretty quickly, so probably we're going to want to, counting by ones on the x-axis obviously won't work here. So, but the y's are growing pretty slowly. 13. Let's maybe, should we count by 3's? 3, 6, 9, 12, 15, that will work. And let's count by 1's on the y-axis. Okay, so 3, 6, negative 5 should be somewhere over here, and that was 1, 2, 3, 4.6. It should be something right like that, I think. 0, negative 3.7, 1, 2, 3.7 should be around here. 3, 6.5 should be about there. And then 13, so 3, 6, 9, 12, 13, and we said that was like 0.8. Be something like this. So I would not expect, I'm not expecting you to know what this looks like exactly. Here, close your eyes. Open your eyes. Okay, but I know that this graph looks something like this. Oops, like I kind of flat there. There we go. So this should be as curvy as this. Anyways, and then our other function was y equals 3, which is going to be without a ruler, something about like that. So this is y3 down here, and this is y4. Now, this curve is going to continue off this way, and it will also continue to move negative, as x goes to negative x, y also will be going to negative y down here. And this is just horizontal, you know that. So again, does it look like it crosses? Not really. So let's make some space here and we'll actually solve the equation. So we have the cube root of 2x minus 5, and this doesn't actually extend forever like I'm drawing it, minus 2 equals 3. So my first step, I want to isolate the radical. I'm going to add 2 to both sides. Close your eyes. Open your eyes. So that gives me the cube root of 2x minus 5 on the left equals 5 on the right. Again, I'm going to cube this and cube this. So this is 2x minus 5 equals 125. When I add 5 to both sides, I'll have that 2x equals 130. When I divide by 2, I get that x equals 65. So we would have to go quite a bit further to the right on the x-axis to see how slowly that's going to approach y equals 3. I'll give you an example for you to try.